Hi everyone, today's lesson is on pyramids, volume of pyramids, lateral area of pyramids, and total surface area of pyramids. So let's get started. Talking about pyramids versus prisms. So we just covered prisms, finding the volume of prisms, the surface area of prisms, and the total, the lateral area of prisms, as well as the total area of prisms. Today we're going to talk about the pyramids and the differences between them that they have. So remember the difference between a prism and or the characteristics or attributes of a prism. And so, for example, one of the attributes of a prism is that a prism will have what we call rectangular faces, okay? So what that means is that the faces, right here, these are the faces. The faces are going along the side. All of the faces are rectangles, whereas on a pyramid, all of the faces are triangular. So let's see. So here's a pyramid. So this is a face. So the face is here. This is a lateral face or lateral edge, lateral edge, lateral edge, lateral edge. But this is a lateral face. See the face? It's a triangle. That is not the same as the shape of a prism. If you notice the shape of a prism, those are rectangles. And I have a triangular one. So I have that shape in the slide right there, which is this triangle. Because remember, your shapes are named by the bases. So if you look at the base and you go, oh, that's a triangle. This is a triangle prism, triangular prism, because of the base, but the faces, these are the faces. Those faces are rectangular, whereas the faces on a pyramid are triangular. And so every one of my prisms, so if this is an octagonal prism, because both of the bases are the same, again, the faces are rectangle. Same thing with this one. Look at the base. This is a hexagonal prism, okay? If you look at the faces, those are rectangles. Whereas this face, again, of a pyramid, pyramids come to a point, whereas prisms have two bases, pyramids have one base. They have a base and a point. We call that a vertex. By the way, more than one vertex. We call these all vertices. Likewise, if these going around are called lateral faces, right? This is called a lateral edge, a lateral edge. And this part right down here, if this is my base, this is my base edge, base edge, base edge, okay? A couple of things as well. So a prism has two bases, and prisms are named by their base. Again, just like I said. So you can look at the base and call it. So like triangular prism. You can look at this one. This is a square prism, okay? This is a octagonal prism, okay? Now this is a square pyramid, okay? And so pyramids have triangular faces. We talked about that. Pyramids have one base, and pyramids are also named for their bases. Now, one of the most important differences between the two is I'm going to make let's say we talked about this in the last section, a trapezoid. And then you make another trapezoid, all right? And then you're going to connect all the vertices, okay? That's how you make a trapezoid. You connect the vertices. All right, so now that's a trapezoidal prism. And this is my triangular, or excuse me, this is my pyramid, but it's a square pyramid. Trapezoidal prism, square, look at the base, square pyramid. Now, in my trapezoidal prism, you'll notice that I can put my height right there, okay? But similarly, that's the same height, that same length there. Those are both the same height, okay? Now, also, if you look at my pyramid, the height of the pyramid comes straight down, but it can't go out to the right. Can't do that, okay? So what we have is something called a slant height, which is something that comes along on the side, and it goes to the bottom of my lateral face. So you'll see that that's also perpendicular out that way. A couple of really cool things, though, that you're going to notice is that, see this right here? That's my height, apothem, and now that became my hypotenuse for this right triangle right in here. So there's some really neat things that we're going to be doing with these shapes and these solids. So let's move on with that. What this does is this slide is just basically saying compare the pyramids and prisms. We just started talking about that. Remember, slant height comes out. So slant height is this distance from this vertice out to the bottom here. Now, the regular height would be going straight down like this right here. See how this goes straight down? That's the height, whereas this is a slant height, so it's slanted. And again, what I was saying with you earlier, you can also connect that, and then what you have is a right triangle there. Similarly, don't forget, this goes to a radius too. And so there's like a lot of things that you could do here, and this could go to my lateral edge as well. All right, so some vocabulary for my pyramid. What kind of a pyramid is this? Well, we're going to look at the base. We have 1, 2, 3, 4, 5, 6. So we call this a hexagonal pyramid. I look at the base, that's a hexagon. So for my hexagonal pyramid, my base, this is my base. I have one base. So this is my base. And if that's my base, okay, then these sides here are what we call base edges, okay? We know also that this side here, see that? That's what we call a lateral face. See how it pops out? That's a lateral face, lateral face. A base edge, just talked about that. And then we have a lateral edge. So this length here is an edge. That's my lateral edge. Lateral edge. Let's see, how many do I have? 1, 2, 3, 4, 5, 6. Tricky. It is a hexagonal pyramid. We should have 6. Now, the altitude is going to come straight down, and it's perpendicular with your base. That's my altitude, okay? The difference between the altitude, which is the height, and the slant height, okay? So remember, the slant height comes out at a slant, okay? It's actually not curved like it looks like in my picture, but slant height comes straight out like this and is perpendicular to this base. Okay, that's awful. Let me fix that. Okay, try this one more time. Okay, let me start from the bottom. Going up. Okay, there's my slant height. All right, now, we call slant heights that it's like a cursive L. Okay, that's my slant height. That's what we call it. It's a cursive L. That's what it is. Okay. So what we're going to do is this right here is just basically saying, what's the difference between this pyramid and that? Well, this pyramid right here is a regular pyramid. So we are happy this is a regular pyramid. This is not regular. You'll notice that the sides are all different lengths, okay? So if it's a regular pyramid, if it's regular, then the base is a regular polygon. All lateral edges, that's these things right here, okay? All of those are congruent. All lateral faces, that's this right here. Those are congruent. Equilateral, because we just said our lateral edges are congruent, they are congruent. So because I have 2 sides, this is now an isosceles triangle, and the blank meets the base at the center, that would be my height. And what's another name for height? That would be altitude, okay? All right, so here's some pyramid formulas, 2 of them, all right? The first one is the lateral area. Now, we were just talking about that, and I'm going to make a square pyramid. So you're going to put a point here. You're going to connect all the vertices. All right, now I have a pyramid. Okay, so the lateral area is this. Now, I want to keep in mind, to find the lateral area, you have an option of finding the area of each of these triangles and adding them all up. That's the lateral area. But we also have this really cool formula that says 1/2 my perimeter of one base times my slant height. That's an L. I'm going to slant that a little bit. Okay, so perimeter times my slant height. Okay, so basically, if my slant height here, remember, see how it comes out to the edge of the triangle? My slant height, let's say, is, I don't know, 3. My perimeter, let's say this is a regular 4-sided polygon, so that's going to be 5, 5, 5, 5. So 5 perimeter, 5 times 4 is 20. So 1/2 my perimeter, 20, times my slant height. My slant height, I said, was 3. So the lateral area, 2 goes into 20, 10. 10 times 3 is 30 units. Area squared. Unit times unit, unit squared. Okay, but the total area, if you notice, the lateral area is just adding the area around the side, whereas the total area is adding the area around the side plus one base. Okay, so so the total area is the lateral area, and we just said that the lateral area was 30 units squared. Okay, we just said that because we multiplied 10 times 3. So again, the lateral area was 10 times 3, 30 units squared. So that's my lateral area. So my total area is my lateral area, which is 30 units squared plus the capital B. Do you remember what the capital B is? The capital B is the area of one base. The area of one base, okay? The capital B is the area of one base. So if this is a regular polygon, these are all 5. So 5 times 5 is 25. Unit times unit is unit squared. So the total area is what we call 55 units squared. So that's my total area. That includes 4 of these triangles, right? 4 of those triangles plus 1 area of this base, whatever that is. Okay, so find the lateral area and total area of this regular pyramid below. So we're going to find the lateral area, and so that's going to be 1/2 the perimeter times the slant height. So again, we're going to go 1/2 my perimeter. So if this is regular, okay, that means all the sides are congruent. So that's 6, 6, 6, 6. So 6 times 4 is 24. So times 24 is my perimeter times my slant height, but they actually didn't give me that. But if I know that these are regular, that means from here to here, half of that is 3. So that means that my apothem, which see that value here, that green value, that's my apothem. That's 3, all right? But then now you know the height is perpendicular, so that becomes a 3, 4, 5 triangle. So that means that my slant height is 5. Okay, so we're going to go 2 into 24, which is 12. And what's 12 times 5? 60. So we have 60 units squared is my lateral area. So now that we found the lateral area, let's find the total area. Okay, so the total area is the lateral area plus the area of one base. So the lateral area, which is 60 units squared, plus, again, the capital B means the area of one base. So the area of this base is 6 times 6, which is 36 units squared. So 60 plus 36 is going to be 96 units squared. And so that's my total area. And just remember, you guys, the difference between the pyramid and the prism is that if I had had a prism, okay, like this, right, connect the vertices to make it look like a prism. There we go. And if to find the lateral area or to find the total area, I would find the lateral area, which is all the way around, right? The lateral area for a prism is perimeter times height, whereas the lateral area of a pyramid is 1/2 the perimeter times the slant height. Anyway, total area is the lateral area plus how many bases do I have? I have 1, 2. So the area of 2 bases, okay? So just keep in mind that there are differences between the pyramid and the prism, and you do need to know those. So again, lateral area is the number of lateral faces. So there's how many of these faces? So that's if I wanted to, let's say, find the area of a triangle and multiply it by 6. You know, I can find the area of one of these triangles and multiply it by 6. And keep in mind, though, that when I'm doing that, the area of one of these triangles, that's the triangle that's popped out. And so an area of one triangle, which is 1/2 base times height. There's my base. My height of this comes out. So that's the height popped out like that. Okay, so you're going to find the area of that. So just keep in mind, and again, when we're talking about slant height, we kind of use a cursive L. All right, so we're going to try one of these problems here, and it says the Great Pyramid does have a slant height of 612 meters, so 612 meters. We need to find the lateral area. So remember, it's a pyramid. So our lateral area is 1/2 the perimeter of one base times the slant height. Well, we know the slant height. So 1/2 my perimeter, but do I know the perimeter? It says a base edge of 481. So my perimeter is actually going to be, what is that? 481 times 4. I'm going to use my calculator. 481 times 4 is 1924. So 1/2 my perimeter, which is 1924, times my slant height, which is 612. So that right here for my lateral area is going to be 1924 times 612 divided by 2, and that's 588,744. So my lateral area is 588,744 units squared. Remember, area is always units squared. Okay, so now we're going to find the surface area. Now the surface area is, again, all the surfaces, right? Including the base. Now sometimes I will say, let's say a word problem might, an application problem might be like, find the surface area of the shape that the painter is going to paint. So the painter is not going to paint the base, right, if it's on the ground. So find the area would not include the area would include the bottom. So then you're looking at just the lateral area. Okay, but the surface area is all the areas. So we're going to look at the bottom also. So the surface area is the lateral area plus the area of one base. Now remember, capital B is the area of one base. And this is my surface area. Now just to be clear, some people will call this surface area, but also surface area is the same thing as saying total area. So if you find the total area, well, that's the same thing as saying find the surface area. And some people like to hear you say surface area because they're like, oh, I need to find the area of all the surfaces. Okay, so anyway, my lateral area, which is this value, 588,744 plus the area of one base. And my base is a square because it's a regular pyramid. So that's going to be 481 squared. So, yeah, okay. So we're going to go, so I'm going to go, let's see, 481. So 481 squared, and that's 231,000. So this value right here, okay, is 231,361 plus 588,744. So plus 784, and that gives me 820,000. So my surface area / total area is 820,145 units squared. Okay, that's my surface area. All right. Now, so the difference between, let's talk about volume. So the difference between the volume of a pyramid, okay, and the volume of a prism. Now, we just talked about volume of a prism in the last video. The volume of a prism, if you remember, is the area of one base times the height, okay? But the volume, and remember, volume is all that space inside. So it's everything. If you were to take a shape and you were to fill it up with sand or dirt or salt or anything, that amount that you would need to take to fill that solid is the volume. That's how much you need. And so this, if you notice, let's say these were the same size shapes, which they're not, but let's say they are. So we've got a square prism and we have a square pyramid. How much is the difference between these two? Let's assuming that the bases were the same, which they're slightly off. What's the difference in volume? How much would it take to fill this up compared to this? And the answer is, and this would be something kind of cool to do and just to check, is the difference is the volume of the pyramid is 1/3, okay? 1/3 the volume of this. So meaning if I were to create, right, my triangle inside here, my triangular pyramid, right? See that? That right there, that shape inside here is 1/3 the amount of this prism. So the volume is 1/3. So volume equals 1/3 area of the base times the height. Okay, so two very, very important formulas. Volume of a pyramid is 1/3 area of the base times the height. Volume of a prism is area of one base times the height. So let's find the volume of this pyramid. Now, the volume of the pyramid, again, is going to be 1/3 area of the base times the height. So 1/3 area of the base. Now, the base, you have to look at it. You got to look underneath and go, well, what is the base? Because remember, each one of the bases are different. So you've got to go, oh, that's an octagonal base. That's a square base. That's a triangular base. So you have to look at the bases and see what they are. This being a regular pyramid, okay, that's 6. So the area of one base, which is this base right here, is going to be 36. Now the height is 4. So this is actually not awful, right? Volume is equal to, I'm going to divide my 3 into 36. I get 12. 12 times 4, 48 units cubed. Now keep in mind, volume is always units cubed. And the reason being, remember, this is my base. My base would be 6 times 6 times my height, which is 4. So see, that's unit times unit times unit. So that's unit cubed. Whereas whenever I'm talking about area, that's going to be unit squared. Volume, unit cubed. So here's an exit ticket, which I expect you to do. I would hope that you would turn off the video and do this and then turn the video back on to check your answers. The base of a triangular triangular prism is an equilateral triangle. So here we go. We have an equilateral triangle and it's a prism. So remember how to make these prisms. You just create the same shape. And then what you do is you just connect your vertices, right? Okay, connect your vertices. So here we go. The base of a triangular prism is an equilateral triangle. So that means that all angles and sides are congruent, which means that's 60. If the base edges are 10, okay, and the height of the prism is 4, draw the prism, check, find the following. Okay, so we need to find, well, we know the height. The height's 4 units. The perimeter of a base, so 10, 20, 30. So that's 30. The lateral area. Now remember, the lateral area is the perimeter times the height. Now we're talking about a prism, not a pyramid. This is a prism, so there's a review. So the base, so anyway, what's my perimeter? My perimeter is 30, so my lateral area is going to be 30 times my height, 4, which is 120 units squared. Now, it wants to find my area of one base. Okay, that's the tricky part. Because the area of one base is a triangle. So the area of one of the triangles, so that's what I need to find right there, is 1/2 the base times the height. Now remember, don't get this confused. This is the base right here, right? That's the base triangle. That's what I'm trying to find. But when I say 1/2 the base, I'm not talking about like the whole thing. I'm talking about just the base of this triangle, which is 10. So that's 10. And the height of the triangle is this length right here, okay? So that means that's 5. That means that's across from 30 degrees. So across from the 60 is going to be 5 root 3. So that height is 5 root 3. So 2 divides into 10 5 times. 5 times 5 is 25 root 3. And so this is the area of one base. So I'm actually going to make this a capital B so you realize that that's the area of one base. Okay, so the area of one base is going to be 25 root 3. So my total area, okay, is my lateral area. Remember my total area? Okay, total area is my lateral area plus the area of one base. So my lateral area is 120 units squared plus the area of one base, which is 25 root 3. And so that's going to be my answer, unit squared. Just leave it like that. You don't have to approximate it. You can just leave it. Lastly, we need to find the volume. And the volume is equal to the area of one base times the height. So the area of one base, oh, we already have that, is 25. Oh, excuse me. Hold on. Yeah, that's right. Area of one base times the height. I thought I was dealing with pyramids again. So 25 root 3 times my height, 4. So that's going to be my volume of this shape is going to be volume equals 100 because 4 gets multiplied by 25. 100 root 3 units cubed. Okay? All right, cool. Now the second one, though, this one is a pyramid. So this is a hexagonal pyramid. So again, to make this hexagonal pyramid, you are going to create the base. And so the base of a hexagon, so let's see here, 6 sides. So we're going to go 1, 2, 3, 4, 5, 6. To make the pyramid, put the point up at the top and you connect the bases. Or the vertices, excuse me. So here we go. We connect all those corners, all right? And now we have a hexagonal pyramid. The apothem of the base is 6. So that's 6 right there. That's what they just said. The height of the whole pyramid is 8. So we know that the whole height is 8, okay? Now, that's okay to write it on the side, but technically it's like what this is here, right? Like that, that's 8, okay? Find the following. So the perimeter, well, I need the length of one side. I don't have the length of one side, but I do have the apothem. This is a hexagon. So you know that the sum of the angles in a hexagon is 720, meaning, remember this formula, 180 times n minus 2. So 180 times 6 minus 2 is 4. 180 times 4 is 720 degrees. So the sum, this is the sum of all the angles, right? But because it's regular, they did use the word regular, that means all sides and angles are equal. So that means I can divide 720 by 6 and I get 120 degrees. And then if I were to cut that up, right? Cut that 120 degrees up, I would make that 60, right? And then, yeah, so across from the 60 is a root 3. Across from the 30 is going to be, divide that by 3 and multiply by root 3. So basically I'm going 6 equals a root 3 and I'm solving for a. So I just need to divide by root 3 and then that works. Get 2 root 3. Let's see. So the perimeter is all the lengths around the side. Well, this length here is 2 root 3. So 2 root 3 plus 2 root 3 is 4 root 3. So one length of one side is 4 root 3, right? So the perimeter is going to be 4 root 3 times 6, which is 24 root 3. And that's units, okay? We also know that this is L, slant height, L, slant height. I don't know that yet. Let's see what we can do. We know that's 8. Let's see. I'm going to go slant height comes down this way. That's perpendicular, but also at the same time, this goes, there's another apothem, right? And I know that's 6, 8, 10. My slant height is 10. My lateral area is my perimeter times, or 1/2, let me rewrite that. My lateral area is 1/2 the perimeter of one base, which I only have one, times my slant height. So my lateral area is going to be 1/2 my perimeter, which is 24 root 3, times my slant height, which is 10. So 2 goes into 24, 12. 12 times 10 is 120, and then you have root 3. And so that is my lateral area. My capital B is the area of one base. So be careful. Capital B is the area of one base. I need to find the area of one base. Now, this is a hexagon. So this could be a little bit tricky because the area of one base being a hexagon, and I'm not going to divide it into little triangles because I do know the formula for the area of one base is 1/2 A and S. My apothem, which is this length here, 6. So 1/2 my apothem times the number of sides, which it also happens to be 6, times the length of one side. So the length of one side is 4 root 3. So I'm going to divide 2 into one of these numbers is 3. What do I have? 3 times 4 is 12. And then I've got 12 times 6, which is 72. So this is going to be 72 root 3. And this is an area, so that's going to be units squared. So the area of one base is 72 root 3 units squared. Now, my total area, remember, is my lateral area. So lateral area plus the area of one base, where the last shape was the area of two bases, right? Yeah. So I did that wrong. So the lateral area plus 2 bases, because we have 2 bases. That's why I knew I was going to get that confused. So I'll come back and fix that. So anyway, so you've got the lateral area plus the area of one base. And so that's going to be, what's my lateral area? 120 root 3 plus area of one base, which is 72 root 3. Oh, and so that's going to be 192 root 3 units squared. And the last thing that we have is the volume. And the volume is the area of one, it's one volume, is 1/3 area of one base times the height. So it's going to be 1/3 area of one base, and the area of one base was 72 root 3 times the height. Where's my height? The height. The height of my whole shape is going to be 8. And so let's see, 3 divides into 72. How many times? 24 times. And then 24 times 8. Remember, don't multiply by that root 3. So 24 times 8 is 2, 3, 16, 17, 18, 19. So that's going to be equal to 192 root 3 units cubed. And so that's that value. So I need to go back and fix my total area. So because, volume and the volume of a prism and the volume of a pyramid, see, for a pyramid, you only have one base, but for a prism, you have 2 bases. So my lateral area, which is 100, so we're going to go total area is the lateral area plus the area of 2 bases. So the lateral area, which was 120 units squared, plus 2 base areas. Now, what was my base area? It was 25 root 3. 25 root 3. So that's going to be 50. So what we have, the only difference here is this is 50. Okay, so we go, answer is 120 plus 50 root 3, and this is all parentheses, units squared, and that's my total area. Sorry about that. Okay, so that's it for today, and start working on your homework, and I'll see you tomorrow. All right, thanks for watching.